Welcome to Geometry Lecture Video 2. So we left off, we want to talk about the circle. And circle, all right, like I said, triangles and circles are the two most commonly used basically shapes that exist in the world. With a circle, some of the terminology changes ever so slightly. So we look at the radius, which is the distance from the center to the edge of the circle. The diameter then is the distance all the way across, and it equals 2 of the radiuses. Instead of saying perimeter for a circle, we call that the circumference, and that's the distance all the way around a circle, which can be found by the equation 2 pi r. The area of a circle then is the equation pi r squared. So let's look at an example. A running track 5 meters wide has the dimensions shown in the diagram. The ends of the track are semicircles with diameter 20 meters. What is the surface area of the track? So we have two different shapes here. So if the diameter, all right, of the circle is 20 meters, that means then I can identify the radius, all right, to be 10 meters. And if the track is 5 meters wide, so if this distance is 5 meters, that means the radius of the inner circle here is 5 meters as well. Since I know this distance is 5 meters, and then the straight part of the track is 100 meters, I basically have two different shapes to identify. So those two circles together, two semicircles make one entire circle, which gives me one full circle with an inner circle and an outer circle. In order to find the area of the track, I need to find the area of the big circle and then subtract off the area of the inner circle. Now, again, good news. The radius of the big circle is 10. The radius of the small circle is 5, which means I have my equation pi r squared. And I simply subtract those two in order to find the two distances. Two areas, not distances. Meters. So that actually that found me the area of these two shaded regions. And then the other shaded regions are rectangles, and that's actually even easier because the rectangle area, and we have two of those, so we're going to multiply by 2. It's base times height. Where the base is 5 and the height is 100, or vice versa. It doesn't really matter what you call it, which is 500, which is 1,000 meters squared. So the area of the track are those two values combined. (1,235.62 meters squared). The arc measurement formula is a pretty useful formula in order to identify the length of a particular side. So I'm told, all right, we have the angle, all right, so at noon, the sun hits you at a 14.45 degree angle. your friend is 1,000 miles from you. What is the radius of the Earth? So if you are person A and your friend is person B, meaning this arc length distance is 1,000 miles, I can then use the concept of transversal here and basically corresponding angles. So if this one out here at angle A or at person A is 14.45 degrees, then that tells me the angle in here is 14.45 degrees. And then I can use this arc measurement formula, which is really just a ratio formula. It's just ratioing the angles to the length of the sides on a circle. So we have the angle is 14.45 degrees, and the total angles of a circle is 360 degrees, right? When you do a 360-degree spin, you turn all the way around. I'm then told the distance on the outside is 1,000 miles, and I'm looking for this distance, all right, the total circumference all the way around the circle. And then I can solve this down, ratios, cross multiply, and then solve for C, which gets me 24,913.5 miles. And then using the circumference of a circle is 2 pi r in order to find the radius of the Earth. Divide by 2 pi. And that gives us the radius of the Earth is 3,965.1 miles. And maybe at this spot it is, the average radius of the Earth is about 4,000 miles. The area of a sector of a circle is basically the equation of the area of the circle and then just multiplied by that sector you are looking for. Because pi r squared is the area of an entire circle, and then any sector is just that fraction. So if you want to identify 1/6 of a circle, you just multiply the area of the circle by 1/6. So, example, John's mother makes the best slice of pie in 3 counties. When she is cutting the pie, John asks for a slice with an 80-degree angle, like we all do. If the radius of the pie is 6 inches, what was the area of the slice of the pie that John got? So if we have an 80-degree angle out of 360 degrees times pi times the radius of the pie was 6 inches, then it's just a matter of calculating away, which gets us 25.13 inches squared. Volume and surface area. Okay, so now we're to 3 dimensions. So volume, all right, turns everything to cubic units. Surface area is still measured in square units because surface area measures all the sides of the object. Now, surface area is slightly more complicated, and so we have more complicated equations, but it's still just finding area on each side of an object. So a couple of our standard objects, rectangular solid or a rectangular parallel piped. All right, length, width, and height. Volume is length times width times height. And the surface area, notice the equation we have there. A circular cylinder. So cylinders are very, very common. Notice that the volume is pi r squared. So that's the area of the circle multiplied by the height of the object. So you still have, all right, the area of a circle and then multiplied by the height gives us the volume. And the equation of the surface area, 2 pi r h. So 2 pi r, that's the circumference multiplied by h. And the surface area would be 2 circles on both ends hence it's 2 pi r squared. Right circular cone. So notice again, pi r squared, but a cone is 1/3 the volume, basically, of a cylinder, which is pi r squared. And then the equation for surface area looks a little more complicated, but this equation right here is just Pythagorean theorem actually written out. Sphere is the one that takes kind of a slightly different form, and it's not nearly as logical. Basically, the surface area of a sphere is 4 circles. The area of 4 circles fit on the area of a sphere, and then the volume 4/3 pi r cubed. So let's look at an example and use some of those equations. A punch bowl shaped like a hemisphere, a half sphere, with a radius of 9 inches is full of punch if we are filling cylindrical glasses that have a diameter of 3 inches and a height of 3 inches. How many glasses can we fill? So let's start with the area of punch in the bowl. So the volume of a half sphere will be 1/2 times 4/3 pi r cubed. All right, since that was our formula for a sphere. We are told the radius is 9 inches. Which gives us a volume of 1526.81 inches cubed. All right, we are now in cubic inches. So we want to see how many glasses we can fill. So we need to find the volume of each glass. So the volume of a cylinder was pi r squared h. We are told the diameter of each glass is 3 inches, which means the radius of each glass is 1.5 inches, right? And so that, whether you're given diameter or radius, always make sure that you're converting back and forth because that might be the biggest trick. And the height of each glass is 3 inches. So each glass has a volume of 21.2 inches cubed. Then in order to find how many glasses we could fill, then you just need to see how much of the punch bowl can fit in each glass. And that number would be 1526.81 divided by 21.2, which gives us 72 glasses. So, looking at another example here, all sides are the same length. Find the volume of the figure below, find the surface area. Now notice that this is not one of our equations that we just had above, right? We just found, right, rectangular, solid, sphere, cylinder, and cone. So this, all right, is a hexagon, all right, that then has a height. Now, the best thing about volume, though, is if you can identify the area, all you ever have to do, because volume, the general equation of volume is area times the height. And so even if we don't have an equation, all right, that's the generic idea. All right, that's basically those equations above minus sphere and cone, which are kind of more complicated. But the volume of the cylinder is just the area of a circle times the height. The volume of the rectangular solid is just the area of the rectangle times the height. Okay, so all sides are the same length, all right? And we are told one of the sides is 2, which means all the sides are 2. All right, picture not drawn to scale. We're also told we have a right angle here, right? So we have right angles, excellent. So, all right, this, all right, appears to be a regular hexagon, but unfortunately we don't have an equation for a hexagon. I could find them each angle, right? But that's not actually helpful. What I can find is a hexagon is actually two triangles, right, attached to a rectangle. So I can identify the area of those triangles actually pretty easily. All right, so the area of the triangle with a height 2 and base 2, 1/2 base times the height. The rectangular solid, all right, has a base of 2, but a height that is unknown. But again, because I'm told this is a right angle, oh, what wonderful theorem can we use? Pythagorean theorem. So 2 squared plus 2 squared equals c squared. Which means c equals 2.83. All right. So 4, right? 2 squared 4 plus 4, square root of 4 plus 4 is square root of 8, which gives us 2.83. Now I have the area of the rectangle. Which gives us 5.66 centimeters squared. Okay, so now let's put it all together. The area of our hexagon. All right, we have two triangles plus the rectangle. Which means I have 2 times 2 plus 5.66, which gives us 9.66 centimeters squared. Then in order to do the volume, like we said, that is area times the height. And the height, we are told from our diagram, is 4 centimeters, which gives us a volume of 38.63 centimeters cubed. All right, so make sure we're paying attention to our units. All right. The other question was surface area. And the good news, we've already found most of this. So we know, all right, the surface area is all the sides. And even though we can't see them, there's a hexagon on top and there's a hexagon on the bottom. So for the surface area, all right, that's 2 hexagons plus, all right, all the sides. Now, good news, all these sides are rectangles with a height or base of 2 and a height of 4. And since it's a hexagon, there are then 6 of those rectangles. So we have 2 times our 9.66 plus 6 times 2 times 4, which is the area of each of those rectangles, which then gives us a surface area of 67.32 centimeters squared. And that's the general concept of surface area. Looking at each shape individually, all right, if you don't have a nice formula. All right, one other last big definition. Bisect means to divide into 2 equal parts. If it doesn't say bisect and you just see a line, you cannot assume it is bisected. All right, because that breaking into two equal parts thing is a big deal. All right. If the line just, you see it on the picture and it kind of looks like it bisects, do not assume that. Unless it actually says, all right, the line bisects, then you can assume it breaks it into equal parts. Okay, example. Approximately how much material is needed to make a tent illustrated in the figure? The height H of the tent is 4 feet, the base B of the tent is 6 feet, and the length L of the tent is 8 feet. Line H bisects side B. The figure is not drawn to scale. So I want to find the volume and then find the surface area of the object. So again, same concept. I don't have an equation for this, but I know that volume is just area times the height. So the good news, okay, so let's fill in our values. All right, base B is 6 feet, so that value is 6. Height is 4 feet, and the length is 8 feet. All right, everything's in feet, just to remind us. Okay, so, all right, I have a triangle, and so this actually, the area of the triangle is just 1/2 base times height, and I have both those values, and that should be a piece of cake. Then in order to find the volume, that means we take the area of that triangle and multiply it by the height, which is 8, which gives us 96 feet cubed. Okay, easy peasy. All right, surface area. Okay, so for the surface area, I see we have 3 rectangles and 2 triangles in each end. Now, the good news is, all right, is that we already found the area of those triangles. All right, so this face here and this face over here are done. Now, what might be more complicated here are the rectangles. So this bottom rectangle down here doesn't actually look too bad. All right, that rectangle, that bottom rectangle, has a base of 6 feet and a length of 8 feet. Okay, so the area of that rectangle is 48 feet squared. Those other rectangles might be more complicated. So let's take a look. Okay, so once again, all right, so my picture is getting all messed up now. So this rectangle here all right, it still has a length or height, whatever, of 8 feet. But what I don't know is this distance here. This distance I need to identify because that is what I need in order to identify it. This is where I think that word bisect comes into place. So because this line bisects, then that creates a right triangle here, which then means I can use Pythagorean theorem to identify that. All right, so we know this is 8, and then this is some side. But we need to back up even, because I need to use that information. Let's just redraw that picture since it got way messed up. Height H, that line bisects, so this actually becomes distance 3, and this is a right triangle. That height was 4. And then I can identify using Pythagorean theorem in order to find this distance, the hypotenuse in this case, which is the side of that last missing rectangle. When we solve that down, we would identify that side C is 5 feet long. And then I can fill that in for my missing triangle, which means the area of rectangle 2 and 3, since they're both the same. Base times height. $40 feet squared. So, all right. The area of the tent, surface area. We have 2 triangles plus, all right, the rectangle on the bottom plus 2 rectangles on the sides. The area of our triangle was 12. Plus the area of our bottom was 48. And those are 40. Plus the 2 sides were 40. Summing that all together gives us a surface area of 152 square feet. And those are the kinds of tricks that I like, the kind of logic that I want you to figure out, as well as that's basically what you're going to be doing in your geometry and measurement project. All right, identifying the surface area and thinking about those things. All right, have yourself a wonderful day.